Alright, in this video, I'm going to discuss a data structure called lists. I'm going to talk about what it is, kind of give a conceptual idea of how it works. Obviously, I'm also going to show some examples of using it both in your just typical script code and how it can be used in functions. And I'll also talk about some methods that are associated with lists. Actually, that's a lot of stuff, so I may split that into two videos, but we'll see. But anyway, to discuss a list, I'm just going to start off kind of going over variables again. Because conceptually, talk about variables. You can kind of picture a variable as some named spot of memory. Say like we were lazy, we just named the variable a. Then this a would have some spot in memory associated with it that would have some kind of value in there. Like you might have the number 4 in there, or 4.8, or you might have, wow, that's horrible looking, some string, like, hello, or what have you. A list starts off the same way. Let's say, just for the sake of being lazy again, we'll just call this one B. Uh, but instead of having a single spot in memory that's associated with that name, you can have multiple spots that are associated with a single name. And well, I mean, conceptually, there's no limit to the number of spots. Obviously, there's going to be a limit because of your hardware size and RAM and stuff like that. But the idea is this would actually, instead of being associated with one single spot, it would be associated with multiple spots in memory that could have data in each one of the spots. And the data actually could be of different types. You can have an integer here, a float there, a string there, and so forth and so on. So while a typical variable only gives you access to one piece of data, this one, the list, can give you access to multiple pieces of data. Now, the other kind of quick thing to tackle with this is how you reference stuff with a list. With a variable, you can just say, A, and it knows to go find this one spot in memory, and you're done. But with a list, since it's one variable name, but there's multiple spots of memory, you actually have to do, you have to actually call, or do what's called indexing them. Um, Indexing, kind of fits. I'm not super keen on the term because indexing kind of makes most people think that if you index, you start at counting at 1, 2, 3, 4, 5, 6, 7, etc. But with lists, you'll actually start counting at 0. That's because even though it's called indexing, you're actually talking about an offset. And what I mean by offset is when you call B initially, it's going to point at this first spot of memory. So, the offset is how far it has to move to get to the piece of data you actually want. If you wanted this first piece of data, it doesn't have to move anywhere to get there. It's already going to be there. So there's zero movement. If you want to get to the second piece of data, you have to move one time over. That's why it's an index of 1 or an offset of 1. To get to this one, you have to move over 2 spots. That's why it's a 2. So the way you do this is if you wanted this first piece of memory, instead of just saying B, you'd say B, and inside the square brackets you put the number of movements you need to make to get to the piece of data you want. So B of 0 would be this. B of 1 would be this. And B of 2 would be right here. So, you could say, you can kind of think of it like that. B of 2, you move over 1, 2 spots. That's going to be equal to the A right there. That's just kind of a quick visual conception of it. Now let's get to an actual example here. I've actually went ahead and saved a file. I just call it list.py. And I'm going to start a variable up. It's going to be a list. I'm going to call it my list. Normally with a normal variable, you would say, like put a string in there or put in a number or what have you. Well, in this one, you're going to start a list. I'm going to start mine off as an empty list just so you can see how that looks. An empty list, you would just start off, if you're hard coding it, you would start off with just an empty set of square brackets. And that would be it. Okay? And, I think this will just print, this shouldn't cause an error, but just to show you that it's empty there, and you can kind of get used to what it looks like. Went ahead and made an empty list, and the first thing I'm going to do is I'm going to go ahead and just run it, have it print out this empty list so you can see what that looks like. And then there you go. It just prints out the empty square brackets because there's nothing in there. But I could turn around and add stuff to this. I could say, I don't know, we'll put the number 1 in there, followed by, just to show that you can have mixed types, which is kind of cool. A lot of other languages that have things that are somewhat equivalent to to a list, which are called arrays. There's a lot of cool stuff you can do with lists that you can't do with arrays, but one of the big ones is most languages that have arrays the notation will look the same, but you can't have mixed data types like this. You'd have to have all integers or all floating points or all, characters, what have you. Okay, now I'll run it again. And you can see it printed out, the different mixed types there. So, kind of what you expected. Now continuing on, instead of printing the entire list, we're going to call one element. So say we want to print this 4.0. We want to print what's there. We'd say print my list in the first offset. A lot of times you'll hear people say this as print my list sub 1. And what that means is they're just saying print my list and then put the brackets there, inside of that put which element you want to go to. Now when I run this code, let's save this. I'm going to run the code now. You'll see it prints out the 4.0. Because what it does is it goes into my list, and I'm telling it to move over 1. So 1 spot from the beginning. This first element is your beginning with the offset of 0. So I tell it to move over 1, which is that, and grab that data and spit it back out, bring it back, and print it. So that's just the very, very basics of the list. It's, and you may wonder why it's useful. Well, I mean, it becomes apparent. I actually have an example that's kind of generic I can show you, but it gives you the ability to actually store multiple amounts of data into one variable, and when you do that, it makes it easier to pass the functions. Or if all the data is, maybe it's information you're gathering, it's all kind of similar or meant for the same usage, then you can have it all compacted together, which is pretty neat. Alright, now we're going to show something else that you can do with lists. I made the statement in the video when I was talking either about while loops or for loops, that there was a third type of loop that I called the for each loop. And I said I couldn't really discuss it until I discussed some other things. Well, you can do this with multiple data types, but lists is the first one I can actually show you using this loop. I actually misspoke. I call it a for each loop because it's basically what it's doing, and if you see it in other languages it would be called for each. But in Python it still just uses the regular for syntax. So I didn't misspeak on that. But what I'm about to show you, if you did like the equivalent like in Java or some other languages like that, it would have its own special name, which is for each. But anyway, on this list here, I could say for x in, and x is just some arbitrary name. I'll show what it does, and I'll explain how it works afterwards. I'll say for x in my list, then indent, oops, forgot my colon, indent 1 over, and then say print x. Okay, and I'm going to get rid of this completely, so the print statement. I'll just comment that out so it's not running. Save it. Then you'll see that it says 1, 4.0, and then A, which are the 3 things that are inside the list. Well, let's kind of break this down. X is a name of an arbitrary variable that I'm going to store data in temporarily in this version of the for. The in keyword, which I just kind of glossed over earlier, I said you had to have it. It was part of the syntax, but I didn't explain why. Well, the in keyword is actually used for things like lists and and other things like that. To check you can use it to actually do comparisons. You could say like I could say if I could do something like I could say print 1 in my list, and when I do that, you'll see that it pops out a true. See, it says true right there, because one of the big uses of the in operator, or the main use for the in keyword, is it allows you to check and see if a piece of data is inside of a list, or I think you can do it with strings also for like substrings and things like that. And in this usage, you can kind of think of it as it's just grabbing each element individually inside. It's grabbing each individual element in my list one at a time, and then storing it in this variable that I arbitrarily named x. And it does it in order from left to right. Or from the offset of 0 all the way to offset of however many you have to go to get to the last piece of data. And then, so the first iteration, it goes and gets the first thing out of here, which is a 1, stores it into x, and then I print x out. Then it goes back up. There's still stuff in here, so it gets the second element, stores it in there, and then prints it out. And then finally, it checks again, there's still more stuff, so it goes to the third element, gets the A, stores it inside of the X variable, and I print that out. It goes back up the top the last time it realizes I've hit the end of the list, there's nothing new, so it stops. So that gives you like a kind of a cool way to iterate through a list really quickly if you need to print it out. Alright, moving on, well actually you can use lists instead of functions too. That's another thing I should show you real quick. It's completely allowed. And I'll try to do something to combine the idea of using a list with the for loop in that form and stuff like that. So let's do a quick function called def print names, because I'm just going to print out a list of names. I'm just going to say name list is what I'll arbitrarily call this argument that I'm passing in. And then what I will do is I'll say for each name in name list, print each name. And then from there I can go ahead and go to that main part of the code. And inside this main part of the code, I will say, what do I want to say? Just to keep it simple, I'm just going to use, in this situation, I'm just going to use all strings, obviously, because I'm saying a list of names, and most people's names aren't numbers anyway. But I'm just going to make some variable called current name, represent the current name that's being entered. And I'll say raw input, enter a name, and then I'll say enter quit to quit, or quit to exit. If I'm not mistaken, on Python, I'm going to just kind of experiment. I believe that since I'm using double quotes on the outside here, I can use single quotes on this individual word, and it'll actually print that word with the single quotes around it. I think it will, but we'll find out. And then I'm going to go on next line. I'm going to want this to continue to ask until they enter quit. So I'm going to say while current name does not equal quit, then while it does not equal quit, we'll do, and this is the idea I was saying earlier, that there's methods associated with a list. I'm going to give you a first taste of it, and I'll explain it more after I show this example. I'm going to say, oh wait, I need to start a variable. I'm going to have a variable called my list, and I'm going to set it to empty brackets, like there's nothing in there right now. I'm going to say my list dot append, and then inside of this append, I'm going to say current name. And then on the next line, I'm going to once again ask the user for the next name and save it in there. So you can see what's going to happen is Python will see this, make a note of the fact that I've got a function that I've defined with a single parameter called names list or name list. It'll ignore that. It'll make sure there's no errors in here, but other than that, it won't run it. Then I'm going to ask the user to enter a name, and they're going to enter that name. And I'm going to go ahead and set up an empty list. That way I can use it momentarily. And as long as they haven't entered quit, which means they're done entering names, then I'll go ahead and append whatever name they entered into the list, which means I just add it to the list at the end. And then I'll ask again, and they'll just keep looping through until they do say quit. And then finally, I'll go ahead and say print names. I'm going to call this function, and I'm going to pass my list to it. And hopefully there's no errors in here. Okay, now as we run this, I'll just go ahead and run it, and you'll see how it works. Alright, it's going to say enter name, type in quit to exit. Oh yeah, sweet, that does work. See, the single quotes are in there. So I'll just say John, Bob, Sam, Dan, and then I'll just quit after that. And then it prints out the individual names there. John, Bob, Sam, Dan, in order. What's happening here, just a quick run over again. I get the initial name, which in my case I'll enter John, and I set up a list that has nothing in it. I just get the notation in there to say, hey, this is supposed to be a list, but I haven't put anything in yet. And then I go to this while loop. Well, current name is John, which is not the same as quit. So I'll go ahead and append John, to the end of the list. And since the list is empty, then the end of the list would be the opposite of 0, the first spot. And then I ask again for them to enter a new name. And in this case, the second time I entered Bob. So I go back up here. Bob is in the same thing as quit, so I append that to the end of the list, which would be the second spot now. I'll put Bob in there. Ask for a name again. And then this time it's Sam, which is in the same as quit. So you can go ahead and add it to the list again. I'll keep asking over and over again. Eventually I do enter quit, and then it breaks out a loop, and I call this print names, which is a function that expects a single parameter. And in this case, my single parameter is a list. But it passes the list up to the the single parameter in our case just happens to be a list, and it gets passed to the print names function, so it jumps up from here to here, and then I'm going to run through each element of the list and print that element out, which in this case would be names. And that's how it works. So you can see that you can actually pass a list to a function just like you would pass a regular variable. Now the thing you may be asking about right here is this line right here, this mylist.append. Well, I said that there were what's called methods associated with lists, and what a method is, basically, let's just put it this way, because it deals with a thing called object-oriented programming, which we haven't gotten into yet. And I don't know if I'll actually. I plan on doing like C++ videos later on, so you'll see a lot of object-oriented stuff there. I don't know if I'll do videos with Python in the object-oriented mode or not. But anyway, this deals with object-oriented programming. All you have to know is there's certain data types you use are actually things called objects, and objects can have methods associated with them. And what a method is it's just a function. It's a function is all it is, but it's just a function that you can only use with that particular data type. Like I couldn't just say, if I had like a variable called, Bob that had like like a number in it, I couldn't necessarily just say, number.append, because it's not a list. It's a different data type. And this append right here is only associated with lists. That's all you have to know about it for now. I may get into more detail if I do videos on object-oriented programming in Python. I don't know if I will or not. But while we're at it, I'll go ahead and show you here. There's a lot of methods you can call with lists. There's append, which we used, which just adds an item to the end of the list. There's extend. You can extend the list out. You can insert an item at a given position. So append just adds it to the end. But with insert, you can put the data into a certain spot in the list, and you can remove things, you can pop and find the index, the count, sort items, and reverse the list in place. These are all methods that are only associated with the list. This is docs.python.org/tutorial/datastructures.html # more on list with that's the website for it, or you can just Google it, but this is actually some of the documentation that Python has in their actual website. The only thing to watch out for if you start playing with these is you'll notice that some of these say, that it is an error if there's no such item. So if for the way this list is set up, say if I had the list, I had this list here that I'm using, that, generically. So I entered John, Bob, Sam, and Dan in there, but then I tried to remove, I tried to remove some other name that wasn't in there, like Steven or something. Then instead of just not doing that, it would actually crash the program because there's an error you have to deal with if this stuff's not there. And later on, I'll get into error handling and what you can do with that to keep your program from crashing in situations like that. But anyway, I think I've talked enough. This video is almost 20 minutes long now. So, till the next video.